Thank you for coming. So let me grab my clicker here. So I don't always do AppSec testing, but when I do, it's in production. Does that remind anyone of something? Yeah, so who's that? Yeah, so there's the Dos Equis guy, right? He the world's most interesting man, right? He doesn't always drink beer, but when he does, he prefers Dos Equis. So this is a bit of a provocative idea. I'm basically saying that you can skip pre-prod AppSec testing and wait until you're in production before you start doing it. So you don't have to skip it. So I'm saying you can, and a lot of folks are already skipping it. So for those folks, this is a no-brainer. But once you do it in prod, I'm going to make the case for you. It's actually better, and it's safer, it's cheaper, it's faster. You'll be much better off, and then you can slowly wind down your pre-prod AppSec testing. All that money and energy you're spending on SAST tools and DAST tools and SEA tools pre-prod, you can do all that better and cheaper and more reliably in production. So a little bit about me before I get too far into this. There's a bunch of logos that are going to come up there. If any of those sort of are familiar to you, shout out. But there's two things I'd like you to know about me first. So are you a Hokie? Carnegie Mellon. So I was the founding director of the Scilab at Carnegie Mellon, and I launched the Build Security initiative at Carnegie Mellon. And so that leads me to one of the two things I would like you to know about me. So my co-founder of the Build Security initiative, you maybe have heard of the BSIM, was the CISO of Comcast. And so she invited me to basically come to Comcast, and I launched a shift left DevSecOps, get developers to own more of security program at Comcast. And over the course of 5 years, I scaled that. So I became a deep student of developer psychology, engineering org sociology, and organizational pathology that you have to overcome. And so I understand sort of the human factors of getting developers to actually take bigger ownership. The other thing is that I'm an active developer. I write code almost every day. I'm the primary author of a dozen open source projects, one of which gets 1 million downloads a month and is considered critical infrastructure by the US government. It's used by AWS and Azure and GCP and essentially every cryptocurrency exchange and wallet out there. So Snapchat and all the other mobile app chat apps basically use my library. So I'm not just preaching security, I'm practicing it with a large project with lots of contributors, and I run it like the program that I'm about to describe to you here. So I'm going to take a little detour, though, before I get into how we do AppSec testing in production, and talk about how we used to do load and performance testing in pre-prod. Does anyone remember those days? Is anyone around when you had to stand up a mirror system to your production system and run it? You're nodding. Was that painful or was that fun? It was very painful and expensive and costly. But we got past that. And I think we can get past it for AppSec testing also with a lot of the same things. So let's review what it was necessary, why it was so bad, and what was necessary to get past it for load and performance testing. So first of all, it was so bad because it was expensive. You had to stand up this duplicate environment. Then you had to write all these test cases. Maybe you could just borrow the smoke test suite, and then you had to run that smoke test suite at load against your application. And then you had to see when a new increment of the product came out, if any of those tests from the baseline changed by more than 20%, then maybe something they added to the feature, the change they made, was going to hurt performance in production. And so you had this sort of calculation and analysis step, and that held you up. You couldn't release until after that, so it slowed you down as well. It's also inaccurate. These test cases are maybe 20 test cases you ran hundreds of thousands of times, so it's fake traffic. It was a fake environment, so you didn't have all of the things you had to connect to. You didn't have all the realities of the internet happening. So a lot of things behave differently in this test environment. And it was missing context. So the same thing, because it was in a different environment, it was not the right context. So what did it take to actually get to load and performance testing? Well, in production. Do it in production. So first of all, the benefits that we have today of doing it in production include that it costs much less. You don't have to stand up this duplicate environment. You don't have to maintain the test cases. Your customers become your testers in that situation. It's much more accurate because it's real. It's the real environment. It's the real code. It's real users. So it's much, much more accurate. It has, some things had to happen, though, before we were able to pull this off. So what did we need? Well, first of all, we needed technology. We needed efficient agents. Agents that could run in production without destroying your performance. Taking 1, 2, 3% maybe of your resources to actually run in production. You needed practices. Practices like canary deploys and blue-green deploys and traffic shaping and feature flags. But canary deploys is sort of the key here, right? So you deploy with just 1% of your traffic being routed to the new version. And then you monitor it. And if the performance is fundamentally different with that 1% of your traffic, then you don't roll it out to the other 99%, and maybe even roll it back for the 1% if it's really bad. But at least you get the feedback given to engineering so they can go fix the performance problems before it affects your reputation and affects most of your users. And then we needed mindset. A lot of folks shifted with DevOps. When you're releasing to production in minutes or hours even, as opposed to weeks or months before, then if you have a problem that you need to fix with a new upgrade, you can do it really rapidly. And so they realize that the risk window is so small in prod that they're willing to do it. Let's reclaim all those resources. Let's stop doing pre-prod performance load testing. Pretty much nobody does that today anymore, but that was a big problem. Security is the opposite, or is not quite there yet. We still do it mostly in pre-prod, but it has some of the same problems with performance testing. It's slow, it's inaccurate. You have false positives in pre-prod, you have false negatives in pre-prod, and you have out-of-context analysis. Also, with DAST in particular, and also with IAST, which we're an IAST vendor, so I'm sort of opening the kimono a little bit. Some of our customers who use our product have a problem because if you don't hit the entire application, you won't get findings for all of your risk. And so you have to write tests or have manually exercise the product in pre-prod for IAST, and you have to have a crawler for IAST or DAST to make that all work. But if you go into prod, you have your users, just like in performance and load testing. They basically exercise the entire app for you. So AppSec testing in prod, we have a new product coming out. It's already out for Java. We're in the process of developing it and releasing it for all the other languages. If you'd like to get access to it, please see me. We have a booth here at the entrance to the expo, Contrast Security. Go over there. I'll be walking over there right after this, so you can meet me there. That is optimized for doing this in prod. It is real time and low cost. It consumes low resources, just like the performance and load testing monitoring tools do. It's much, much, much more accurate. So we needed to do some things in order to make this happen. And the technology has evolved so that we have done those things we can. First of all, we need the same thing you needed for performance and load testing. We needed low resource consumption agents, highly efficient agents. We have those. In the time that I've been at Contrast the last 3 years, our agents have gotten improved by an order of magnitude their load, the load they put on the system. And this new product that I just described has this dynamic sampling capability where it essentially turns itself off as soon as it gets the information it needs. So it takes a fraction of 1% of the resources to actually get complete 100% coverage that you could never get before. The practice is you have to actually just install the agent. which is not trivial. I'm not saying that's a zero effort thing. You have to actually install it into your clusters, install it on your apps that are running in VMs, etc. And there's some limitations to that, and some things you'll have to do to make that happen. But that's the practice that you'll need to have. That's all you need to do, though. You don't have to actually use canary deploys. It essentially is doing its own canary deploy because it turns itself off as soon as it gets the information it needs. But you have to be convinced to at least try it, and that's essentially what I'm here to do to try to convince you. So how does it work? So let's solve SQL injection forever. So this is a typical snippet of code that could potentially be an SQL injection risk. So you've got this string SQL coming in from an untrusted source, like a user input or a parameter on an API. We know that this is an untrusted source because our agent has basically tracked it from when it came in to when it got to this SQL execute SQL statement. So normally you would run the query and you would be done with it. We modify the code at runtime. We insert ourselves in the Java class loader, and we see as the code is loaded, and we literally modify the code. We essentially add this one line to your custom code. Runtime protection module, enforce trust boundary. We're basically putting a trust boundary around this execute SQL statement. What that does is it calls out to a subroutine. We also add modifying the code that sort of does what I'm describing here. The very first thing we do is we see if the library you're using, we know that was loaded, right? The SQL library or the ORM library you're using, we saw that was loaded because we're in the class loader chain now. We've seen everything that got loaded. We know the version of it. We can look up to see if there's a publicly reported CVE against that version of that library. But we go one step deeper. We don't just see if there's a publicly reported known vulnerability. We can actually find unknown vulnerabilities. We found Log4Shell years before, Log4j, the vulnerability in Log4j years before it was actually ever attacked with Log4Shell. Last week we found a vulnerability in Netflix Genie, a very popular analytics product, open source product that's put out by Netflix. We're finding these dependencies that have unknown vulnerabilities. The one we found last week was a CVSS 9.9. It's now CVE. It's now a known vulnerability, but we were detecting it before it was ever recorded as a CVE. So we can replace your SCA tool with this. We also detect and report to the developer that the data that came in, the string SQL that came in, didn't get sanitized before it got to this execute SQL statement. And so we can report that to the developer as a vulnerability so they can permanently fix it. But in the meantime, we can replace your SAST tool. We basically can replace your SAST tool with this. But we go one step further. We don't just report the vulnerability. If the data that comes in looks like an attack, semicolons in it, quotes, single quotes where they shouldn't be single quotes, if it changes the meaning of the SQL statement that was originally there, we can sense that actually someone's trying to attack, and we will literally throw an error and we will block the attack. So not only do you get the feedback that a SAST tool has, you get runtime application self-protection. Basically, you can replace that functionality of your WAF. You can turn off the blocking app signature blocking capability of your WAF because this does it much more efficiently and much better, much faster. So this is my closing slide, essentially. So just conceptually, we know all the dangerous function calls in your app. We scan your app as it's loaded. We know that execute SQL is a dangerous function call. Spawning a command line is a function call. Deserialization is a function call. We know those. We wrap them with this trust boundaries. And out of that, you get these 4 capabilities. You get the ability to detect vulnerabilities in the code you write. You get the ability to detect vulnerabilities, both known and unknown ones, in the libraries you're using. You get the ability to see how your product behaves, observability capability. So I didn't mention this on the prior slide, but we see what external resources, what databases your application connects to. We actually can draw a threat modeling diagram of your application. We have we call it the flow map. You can see all the databases that are connected to. So we can enhance observability capability, and we can block attacks against that. So, oops, I went backwards. Thank you. I think that's all the time we have.